Welcome back to another SPACEGASS video tutorial. Here's a quick intro to the reinforced concrete beam module following New Zealand Standard 3101. Imagine we've got a continuous reinforced concrete beam displayed on the screen. The load has been applied, and now the goal is to design the reinforcement so it can handle that load effectively. Using SPACEGASS is pretty straightforward. Just pick the members that form the beam, right-click, and select Edit Concrete Beam. Easy as that. By default, SPACEGASS will automatically figure out a reinforcement arrangement that works for your design. SPACEGASS breaks the beam into 5 distinct zones, with each zone having its own specific reinforcement arrangement. When you click on a zone, the reinforcement details like longitudinal bars, stirrups, concrete cover, and more show up on the left panel. This graph illustrates the bending moment capacity along the beam and compares it to the actual bending moment experienced by the beam. In this example, the design proves to be quite efficient, as the bending capacity closely aligns with the actual bending moment at the midspan of the beam. In the first zone, being a fixed support, there's a notable negative bending moment. To counteract this, a substantial amount of reinforcement is placed near the top of the section by SPACEGASS, which makes perfect sense. Of course, you can adjust the reinforcement arrangement however you prefer. For instance, here I'll change the bottom of the mid-span beam to have 4 bars, instead of the 3 bars suggested by SPACEGASS. As a result, SPACEGASS recalculates everything automatically and updates the bending capacity graph with the new data. On top of that, SPACEGASS can calculate beam deflection too, covering short-term, long-term and total deflection. SPACEGASS takes torsion into account as well, calculating the extra longitudinal and transverse ties needed for torsion. It then adds these to the reinforcement required for bending and shear. These two beams are under the same loading conditions, but one has a slight amount of torsion affecting it. Let's dive into how SPACEGASS handles the designs for the beams, one with torsion and one without. It will be interesting to see how the reinforcement adjustments account for the extra forces introduced by torsion. Here's the beam without torsion. You can see that at the left end it's designed with 4 N20 bars and a tie spacing of 105 mm. On the other hand, the beam with torsion is designed with 5 N20 bars. This is because torsion demands extra longitudinal reinforcement. Interestingly, the tie spacing for this beam remains the same, though that's not always the case in general. SPACEGASS produces a detailed report that covers the reinforcement layout and design actions for the beam, giving you a comprehensive breakdown of all the key details.